So we're still working on factoring trinomials where the square term is 1. And so we've already done some examples in the last video. So here I'd recommend that you do is go ahead and hit pause on this video. Take a couple minutes. Try to work out number 9 and number 10 by yourself. And once you've done that, then go ahead and click on the play to then see how we worked it out here. So go ahead and hit that pause button. Alright, so let's take a look at how we do this one. So again, I'm going to be looking at this last number, 55. I want to find pairs of factors that add up to 16. So 1 times 55 gives me 56. That doesn't work. 2 does not go into 55. We can do 5 times 11. And notice right there, that's the pair I want. I'm not going to worry about going any further. Once I find that pair of numbers I need, then I'm just going to go and stop. I'm not going to worry about trying to break this down anymore. In this particular example, I don't think you can find any more factors to break down. So now, I'm going to just go ahead and write this in factored form. N plus 5, N plus 11. And so that would be my answer. Let's try this next one. So again, I'm looking at 20. And I got to find factors of 20 that add up to negative 12. Well, 1 times 20 gives me 21. 2 times 10 gives me 12. That gives me the right number, but the wrong sign. Now, whenever you have the right numbers, but you get the wrong sign for the middle term, you want to change the sign of each. So if we go back to the previous page here, right here on step number 2, if you get the opposite sign for B for the sum, then change the signs of M and N. So here, I really need to make both of these negative. Because negative times negative is a positive, so I still have a positive 20. But now when I add the negative 2 and negative 10 together, that gives me a positive, or it gives me a negative 12 instead of a positive 12. And that's what I want. So this is the combination I want. K minus 2, and K minus 10. Again, I can FOIL it out, verify, get that middle term of negative 12K. So, let's take a look at number 11 together. Then I'll have you try some more of these on your own first before we go over them. Actually, we broke out 55 over here. That's 1 times 55, 5 times 11, and there's no other way to break down 55. That adds up to 56. That adds up to 16. There's no way we can get a 5, let alone a negative 5. So remember, when this does not factor, we say that it's prime. Even if I go here and make both of them negative, since you might think we need to make them negative since that middle term is negative, I still can't get that to add up to negative 5. I get negative 16 and negative 56. That doesn't work. So go ahead and pause the video again and try 12 and 13 on your own. Okay, so let's take a look at these. Here I'm looking at 16. Need to break down 16. We can do 1 times 16. That adds to 17, doesn't work. 2 times 8. Well, that adds up to 10. So that is what we want. Now, a question comes up here when you're writing this. Does it matter if I write the a plus 2 first and then the a plus 8? Or can I write the a plus 8 first and then the a plus 2? And the answer is it doesn't matter. Multiplication's commutative. If I can write those factors in either order. So if I want to write a plus 8 in parentheses first and then parentheses a plus 2, that's fine. Let's take a look at number 13. So here we have 100. I can do 1 times 100. Now, since that's a negative 20, I need to make both of these negative. That's a negative 101. Negative 2 times 50, negative 50, excuse me. Well, that's a negative 52. So negative 3 doesn't go in there. Let's try negative 4 and 25. Nope, that doesn't work. So we're going to just kind of keep going. Let's try negative 5 and negative 20. That adds up to negative 25, doesn't work. 6 does not go to 100, 7 doesn't, 8 does not, 9 does not. How about 10? And there it is. That adds up to negative 20. That's the combination I want. So we're going to rewrite this as x minus 10 times x minus 10. And that can be rewritten as x minus 10 quantity squared. Let's try the next one. So let's look at 54. So I can do 1 times 54. That's 55, so that doesn't work. 2 times 27, it's 29. 3 times 18 is 21. Let's see, 4 will not go in there. 5 will not go in there. Let's try 6 and 9. There it is. That's the combination I want. Now, you may remember that we mentioned earlier, whenever you're doing a factoring problem, you always should check for a greatest common factor. Otherwise, if I start breaking down negative 400, that's awfully large. And we certainly don't want to do that. So, but notice here, each of these have a common factor of 10. So let's factor out the 10 first. That gives me n squared plus 3n minus 40. And now I'm working with negative 40. That is much smaller to work with than 400. That's doable. It's negative 40. So one factor has to be positive, one has to be negative. Since the 3 is positive, we want the positive factor to be larger. So I'm going to do negative 1 times 40, that's 39. Negative 2 times 20 is 18. Negative 4 times 10 is 6. Negative 5, there it is, negative 5 and 8. Be sure when you write this out that you bring the 10 down. You cannot forget about the 10. Otherwise, Alex will stick out its tongue at you and say it's wrong. So then it'd be 10 times n minus 5 times n plus 8. So for number 16, we want to do the same thing. Greatest common factor is 5. Let's take that out first. So that'd be v squared minus 4v minus 12. And now I'm going to be working on breaking down factors of 12. Or excuse me, negative 12. 4 is negative, so I want the larger number to be negative. So I'm going to do 1 times a negative 12. That gives me negative 11. 2 times negative 6. Bingo, right there. We just go ahead and stop because I found the factors I need. So I'm going to put v plus 2 and v minus 6. So the factoring technique we explored now is when we're factoring a trinomial where the coefficient of the square term is 1. If that coefficient is not 1 after you pulled out the greatest common factor, then we're going to have to use another factoring technique. It kind of is built on this, but we have to make some modifications. Number one, we're going to have to multiply the coefficient of the first term with the last term to get this product here. And once I find these pair of factors, I'm going to have to rewrite the middle term using those factors and do our factoring by grouping. So it's going to be a little bit more complicated. But we'll take a look at that in the next video.